everyone, my name is Chendi Liao. Together with my colleague Donnie Yunardi from Roche and Genentech, we are happy to showcase a product we've developed within Roche and Genentech over the past few years. It's an open-source, scalable R-Shiny-based framework called teal. This framework aims to unlock the power of interactive data exploration and ultimately accelerate insight generation from data. I'll start by giving a background of the teal framework itself, how it and why it got started. Then I'll provide an overview of the various components and extension of the teal framework, and some real use case examples of teal being applied in the clinical trial space. I will then pass to Donnie, who will highlight the anatomy and key features of the teal framework with a live demo of an app in action, followed by some additional resources to help you get started. Analyzing clinical trial data requires multiple ways of presenting and interacting with our data. Thinking about how we work traditionally, as a data scientist sitting on a clinical trial study team, we may need to generate a Kaplan-Meier plot on the overall survival of the study patient population per the statistical analysis plan. But a week later, after we deliver the outputs, a stakeholder reviewing the result may ask, well, how does the progression-free survival curve look like in our patients? Do they follow the same trend as OS? Then maybe another week later, a different scientist asked to see the PFS data in a subset of patients who tested positive for some genetic mutation at baseline. For the scientist interpreting the result, much time is spent on waiting for someone to attend to their request. And then for us data scientists, we repeat a lot of redundant work in order to deliver on some very small changes. So what can we actually do to improve efficiency? Wouldn't it be wonderful if we can have a tool that can do something like this? Some kind of easy-to-use web apps to enable our non-data science colleagues to easily and reproducibly analyze and explore data by themselves, switching out the analysis endpoint or subsetting the analysis population with just a few clicks. But Roche Genentech is a large company. Training each and every one of our data scientists to become an expert web app developer doesn't seem feasible. So instead, we look towards R-Shiny as a programming solution that readily offers the best of both worlds. The ability to create web apps while still being able to tap into the robust set of statistical analysis functionalities. And using R-Shiny, we created a framework called teal for easy interactive data exploration. It centers around modularized, reusable, and stackable building blocks, organized into a collection of our packages, each with its specialized functionalities. The framework abstracts away a lot of the complexities of building a Shiny app that allows the app developers to focus on developing the analysis content itself. So ultimately, it streamlines the creation of R-Shiny apps that packs many valuable features, including dynamic filtering of the input data, code generation for better reproducibility, a reporting engine for easy cataloging of the result, and a set of purposefully designed and curated analysis modules that provide data summarization and/or data visualization. In comparison to a traditional R-Shiny app, the app developer would first need to gather and line up all the input datasets. Then, depending on complexity required, you might have to write a long and massive UI server script with interdependent reactivities. It's like a huge truck with one single cargo hold, and you're just trying to dump everything into it. With the teal framework, it comes as a freighter cargo ship already built for you. Then everything else comes as a modularized component like shipping containers. The input data gets its own container. Each container may have a different data structure, making the framework really data agnostic. It's flexible because you can freely choose which analysis module to load in the app, easily swapping out one summary table for another graphic visualization of your choosing. You can also add as many analysis modules as you like, and cumulatively, they can provide 360-degree of the data you're exploring. Modularization is also very important for collaboration and crowdsourcing in the open source development approach. Different developers can work on different modules at the same time without interfering with each other's progress. But ultimately, as an app developer, you don't need to worry about how to build a UI component or the exact server logic or the reactivities of Shiny. You can simply use the framework, then choose already built modules from a catalog, then hit plugin and play. Now that you've heard about the modularized concept of our teal framework, you can have a better visual understanding of the building blocks with this overview product map of our teal framework and the family packages. We have several foundational component R packages for scalability and easier maintenance, such as teal slice, teal data, teal transform, teal logger, and teal code. Each has its own specialized purpose, as their name suggests, but together with teal, it creates the R Shiny app framework. There are also packages like a teal widget, teal reporter, and teal gallery that, together with the framework, enables teal modules development. We have several curated and centrally maintained teal module packages that offers a large catalog of data analysis modules. Teal Modules Clinical offers general visualization for exploring any data types. Teal Modules Clinical were designed to analyze CDISC data, specifically for clinical trial reporting. The module package provides the UI and interactivity logic, but it relies on a separate R package called Turn to perform the calculation or tabulation that produces the actual statistics that's going to be shown as output within the Shiny module. Teal Osprey, coupled with the Osprey calculation package, are modules specifically designed to analyze early phase clinical trial data that focuses on safety results. Teal Goshawk are modules for analyzing and visualizing laboratory and general biomarker data using the Goshawk package for calculation. And lastly, we have Teal modules Hermes and the Hermes package for standardized processing and analysis of high-dimensional RNA-seq data that require more specialized handling and statistical approach. This is a more wordy description of what I just talked about. In the interest of time, I will not repeat the details, but make the text available for your reference when we share out the slide. At Roche Genentech, our data scientists have already been using teal broadly across many areas of our daily work. Within the traditional clinical trial setting, we've been building teal apps as an alternative method to enable quick quality control and the validation of our trial data analysis outputs. We've been providing teal apps directly to our stakeholders and clinical scientists, who typically may not have direct access to raw data itself, and allowing them to perform trial monitoring or ad hoc exploratory analysis themselves. With the code reproducibility and reporting feature, they've also been actively using the app to generate contents and materials that goes to support internal decision meetings, especially at the study milestone event. This greatly reduces the turnaround time and the workload on our data science teams. It's also one of the most efficient tools for any pooled data analysis due to the dynamic filtering feature and the standardized UIs. One can easily stratify and or combine data as desired. Outside of clinical trial setting, teal has also been used to explore high-dimensional biomarker data types, such as RNA-seq data, as well as off-label use of our pharmaceutical product in real-world setting. We've also seen some creative usages of the teal app for data quality monitoring and even operation analytics, areas we did not purposefully expand into, but was nonetheless picked up by the respective teams due to the valuable features the teal framework offered. Now that you've heard me talk conceptually about all the great things teal offers, I will pass the ball to Donnie, our teal development team engineering lead, to take you on a journey through a teal app to really see it in action.
Thanks, Chandy. Hello, everyone. So I'll be doing a live demo to show you what teal looks like. But before that, we'll go through some installation process and I'll share with you the best way to play around with teal products. Teal is an open source project that's being hosted in GitHub. You can install teal directly from GitHub, but it is recommended that you set up GitHub Personal Access Token. This is because we're using a package called Remotes to install all of teal's framework from GitHub API. Personal Access Token is needed to prevent rate limiting. Once you have your token, you can run the code provided. This will install the stable version of teal and its dependencies. This is an example of a teal app, and I will demonstrate its anatomy. To begin, there is a header which displays the title of the teal app. Following that is a menu bar containing tabs. These tabs represent different teal modules that provide various analysis for users to explore. Next, we have the Reporter feature, which enables users to capture multiple outputs and analysis into a downloadable report. Then we have encodings. Encodings are controls specific to the module that allow end users to customize the output. The Show Our Code button provides code reproducibility. If you have interest on the output you see, clicking this button will reveal the code necessary to reproduce it. Debug Info button is a debugging tool that can be useful when developing a teal app. When encountering issues, this will direct you on what to fix next. The middle portion is the main visualization or output for the module's analysis. The Filter panel is teal's feature that allows users to filter or subset the dataset interactively within the module. The footer provides space for additional information. User can toggle the filter panel section by clicking the hamburger button. Doing this will hide the filter panel and increase the dimension of the output in the middle. Lastly, 3 buttons allow users to interact with the output image. The left-hand button enables downloading, the middle button provides a better view of the output in a model, and the right button enables adjusting the output's dimension. I will now show you a live demo of a teal app and its features. I'm using Posit Cloud Workspace to do this live demo, and this is a great way for our users to explore the teal products. I'll provide more information on how everyone can join the workspace at the end of this presentation. Let's start the teal Playground workspace. I'm going to run an example app from the teal gallery R package. This is an R package where user can see teal example apps based on the type of analysis. For this live demo, I will run the example app for efficacy analysis. Once the app is loaded, let's play around with the demographic module. We will use the filter panel to subset our data based on sex. As I select different values, the output will get regenerated. To remove the filter on the dataset, you can click the X button here. Now, let's head to a different module. This time, we'll use the kmplot module. This output looks too big for me, so I can click this button to adjust the height of my output. That looks much better. If you like the analysis or output that you see in a teal app, you can click the Show R Code button to see the code that you need to reproduce it. Once you see the model, you can click the Copy to Clipboard button, bring it over to your local RStudio session, and run the code locally. As you can see, I get the exact same output with the one that I see in the teal app. If you're interested on multiple analysis, or if you want to make a report from your exploration, you can use the reporter functionality. I will demonstrate how this feature works. First, let's add some filters to the dataset where I only want to see female subjects. If I like what I see, then I can click the plus button to add the analysis to my report. I'll add some comments and click the Add Card button. Let's go to Time to Event module. We'll remove the filters and add the analysis to our report. Just like before, click the plus button and add some comments and click the Add Card button. Assuming that's all I need, let's go to the Report Previewer module to see all the cards or analysis that I added. I can click the card to get a preview of the report. Here I can see the table output, my comment, and the R code to reproduce the output. On the left-hand side, we have several metadata input that you can set before downloading the report, such as author, title, date, and the format of the output. We'll stick with HTML for now, and let's click the download button. We will get a zip file containing all the assets necessary to recreate the report. This includes image file for visualization, RDS file for tables, the HTML file, which is the report itself, and R Markdown file to recreate the report. Let's open the R Markdown file and add more annotation. I will add a new heading and dummy text. And recreate the report by knitting it. Now I have updated report with more context. There are two ways to play around with teal products without polluting your local environment with installation. One, by accessing the teal playground workspace that you've seen in the live demo. And you can do that by clicking the link that I provided here. Another way is by using the public Docker image that is loaded with teal products ready for you to use. The link to the Docker image is also provided here. I mentioned about teal gallery before and how this is a great R package to see an example of a complete teal application based on specific analysis. You can simply run launch app function and provide the example analysis that you wish to see. We also publish these example apps in a public shinyapps.io for extra convenience. We provided links to these public apps in the slide, and the information is also available in the teal gallery repository in GitHub. Teal is part of Pharmaverse. This is Pharma's stack of curated open source R packages to enable clinical reporting from CRF to submission, backed by pharma community. We follow the Pharmaverse guideline for support. If you have any question or feedback, you can reach us via GitHub issue or Slack in Pharmaverse workspace under Teal channel. In addition, we are working on a course called Hands-on Clinical Reporting using R in Coursera. We'll inform the community again when this is ready for sharing. Since Teal is an open source project, we are looking for collaborators to develop this framework further. If you're interested, you can help us out by providing your contribution in GitHub or join us on the Teal channel of Pharmaverse Slack. If you're an organization wanting to adopt Teal and co-develop it, you can get in contact with me or Chendi. We would like to acknowledge those who has been contributing to this project. We won't be here where we are today without your amazing dedication, so thank you, and we look forward to see more collaboration in the future. Thank you for listening. It's been a pleasure to be able to share Teal to you. I hope this has been informative, and we look forward to your feedback and collaboration. Have a great day.